Really glad to be with you all today. My portion of this presentation, I'm going to break up into three parts. So first, just a quick overview of Clydo itself, because many of you are probably not familiar with Clydo. I'll touch on a little bit more detail on our ongoing collaboration with Restream. And then we'll get into the meat of the discussion. I really want to frame it as enterprise tokens and thinking about what those are and why they're relevant. And then we'll step through some real world examples that, frankly, one of the most fun things about my job is working across a lot of different interesting projects. And I think Restream has several examples of such, and just seeing how these technologies are really reshaping the way that enterprise IT works. Okay, so let's jump in. First, just a few minutes on Clydo itself. Clydo is an enterprise SaaS company. We're a startup headquartered on the East Coast of the US in Raleigh, North Carolina. And we're a leading infrastructure provider for enterprise blockchains. There are several, for those who may be a little bit familiar, there are really several different flavors of open source protocols that are out there. Clydo is working across all of those. And we've built a number of complementary technologies that are part of the SaaS platform that work plug and play. For our customers like Restream that are building really ambitious industry-wide platforms, we help them to build out their own app clouds and platforms to serve and to work with their members. We have a global footprint and a number of clients around the world, and I'll speak more about those as we dive into some examples. But really want you to think about multi-party ecosystems and the collaboration, the friction that exists today, and the promise that blockchain represents to maybe build more efficiency to unlock new potential business models or streamline business processes to make those ecosystems more efficient. Our sort of SaaS platform and technology, you can think of it almost like a consortium or a business network as a service. Pat was just mentioning a minute ago that one of the ways they think about Restream is to think about it like a network of businesses that interact with each other on a daily basis. I mentioned we're working with a number of clients around the world. Here's a subset of some of those, your peers in your industry and indeed across many industries and geographies. We really do focus on enterprise. So we're built for enterprise things. We understand that you're regulated, that you have information security teams, that you have standards that you adhere to as well. And so we're built for that. Things like key management, things like compliance and certifications, and the other things like disaster recovery and 24/7 support and so on. But on this platform, at the end of the day, it's really about accelerating these projects and these initiatives, giving our clients something like an easy button to build on more rapidly. And so just touching upon then our relationship with Restream, Pat mentioned Canopy, and some of you may be familiar with that, some of you may not. And it's not the focus of the presentation today, but I would encourage you, if you are interested to learn more, to reach out to the Restream team. When you think about what we're trying to do differently with this IT technology than all the other ones before it, the idea of a decentralized platform, a decentralized ecosystem where each member, sort of in this light gray box, are deploying their own stack of technologies, but a unified stack of technologies. It's not our sort of disparate private legacy back office systems that we all have today that are sort of black boxes to everyone. We're moving forward in this new world in a much more coordinated fashion, building applications and defining these technology stacks. But when we deploy them, we're not centralizing everything. We're still maintaining a high degree of decentralization that a blockchain gives us. But it's important to realize that a blockchain is really just one technology. We think of it like the beating heart in these business networks, but there are other technologies that need to come together as well. Data needs to remain private and be stored. There needs to be connectivity to back office systems. There needs to be, identity management systems so operators can interact with these systems. And then within the network, a lot of data is not suitable to go on a blockchain. It needs to be exchanged or moved around privately. Sometimes data needs to be broadcast in an efficient public way. And then tokenization and digital assets is really the focus of what we're diving into today. But I wanted to give you a sense of, maybe a architecture view of how these business networks look at a high level. And Canopy indeed is Ristream's approach and platform for that. There have been generations and evolutions along the way. But there are a number of benefits of the Canopy 3.0 architecture, with which Pat and team would be happy to really dive into with you. But things like advanced privacy mechanisms, building a resilient event-driven architecture, being multi-protocol, and getting to things like digital assets as well are benefits. Okay, so that was a quick tour of a little bit about Clydo and some of the work we're doing with Ristream. Now let's dive into and talk about enterprise tokens a bit. And as we transition to that, I want you to continue to think about that sort of high-level architecture diagram that we talked about a minute ago, and realize that enterprise blockchain as a thing is really sprung up out of the larger blockchain crypto world and is its own wave of innovation within the enterprise. And we tend to focus on back office processes, areas where there's lots of friction between parties of different enterprises, and thinking about how to streamline that. And here's a few examples to just remind you of how legacy and brittle our systems are today. In fact, there's a whole fresh set of examples that COVID has exposed around supply chains and value chains and cross-border movement of things. If you think about stocks taking 3 days to settle, retailers having really hard time tracking where the toilet paper is, right? In their lack of visibility into the depth of supply chains, whether ingredients are genuine or not, and guaranteeing that, the risk of fraud, goods moving through ports and so on. You really can get a snapshot view of the global economy running through different sectors, and yet the same problem is there over and over again. The level of digitization is not where it could be and where it's rapidly moving to be. And there's a lot of value that's trapped in these legacy systems. And enterprise blockchain, and the promise of enterprise blockchain, is to really get at those legacy applications and systems and reinvent those on a shared ledger that has a single source of truth, and to automate how data flows across parties and how parties stay in sync through smart contracts. That's sort of the big idea. I think probably a lot of the folks on the call are familiar with that, but in case there wasn't that baseline, I wanted to say that because it's really relevant for tokens. So keep that in mind as we talk about enterprise tokens. If you take anything away from this talk today, I want you to keep 3 high-level thoughts in mind. One is that tokens are for enterprise. Two, hopefully that's going to become abundantly clear. The second thought is that, the idea of tokens is, it's really hard to wrap your head around. I get that. I hear that all the time. But boiling it down, tokens are just, they can represent any asset or thing, whether it's physical or digital. And we'll go into that in detail. And then the third thought is that once you've done that, tokens give multiple parties a single common view of information you can trust about that thing. And we'll see why that's powerful. So let's go into the first thought of tokens are for enterprise too. We hear a lot about these, Bitcoin and some of the NFTs Pat may have gotten into in that first session in the series. But today we really want to think about these other things, real world assets like cars or buildings, if you're more in the commercial space, or deeds and titles and complex instruments, financial instruments. Those things can become tokens too. And we'll see what we can do with that. But enterprises need to collaborate on, with, about things, assets, data. You need to move value from party to party. And tokens are highly programmable. You can just define what that thing looks like on the blockchain. You can customize that. And once it's there, you have a single source of truth. Well, once that token gets deployed or instantiated. And on a blockchain, you can decentralize that. You can have a level of decentralization where no one owns or is in control of that thing, but everyone is helping or participating to maintain it within the network. And so the need for enterprises to collaborate on things that are core to their business, and the fact that tokens on a blockchain can represent anything in a very flexible and customizable way, means that tokens can meet the needs of enterprises in a unique and new way. And what we're starting to see is this is unlocking potential for new and different or improved applications, solutions, and sort of meta business processes that span multiple parties. All of a sudden, you can rebuild those in a much simpler way that can be automated and streamlined, and can be new and different in exciting ways. So that's part one. Tokens are for enterprises too. Part two, tokens can represent any asset or thing. Let's think about that for a second. I said that really a token is just a programming construct that exists. That's part of a blockchain protocol. There's a lot of history to that, and I think you may have stepped into a little bit. There are different types and flavors, which we'll get into more in a minute. But these things are flexible and customizable. They can be, because they're code, because they're running as code, they can be automated and they can be instrumented. But the most basic protocols or the most basic standards that have emerged for tokens have very simple functions, things like how to create them in token lingo, that's to mint them, how to delete them in token lingo, that we call that a burn, but just deleting a token once it's what's there. You can transfer or change the owner of that token. And of course, you can create any sort of function or attribute about that thing that you'd like. And so, I saw on one of maybe there was the second talk, you talked about digital twins. And I'm going to revisit that because I think that's a really important, perhaps the most important way that tokens can be leveraged with enterprises. That's what we're seeing today. And a digital twin is just simply the fact that an asset lives in the real world. And the idea of creating a digital representation of that thing on a blockchain, where you can more easily track the state of that thing as on an ongoing basis and keep multiple parties in sync. It sounds really basic on the surface, but it hasn't been done before, and so it's new, and therefore it's becoming a really powerful tool. And I mentioned that you can build a degree of automation on top of that. You know, what are the rules when the ownership of that thing changes? If you can transparently display that, and all parties know about the rules of the road, then that those rules exist in code that are automated, that can be instrumented, that can be driven by rules, and that can be triggered off of events. Now you're really fully into the digital world, and building these things within an ecosystem means you can take the degree of efficiency to just a much higher level. So let's look at, you know, the fact that a token isn't just one thing. There are different kinds of tokens, and I know Pat drilled down into this, so this is more of a recap. But you know, there's a category of in blockchain lingo that are called fungible. That just means, like, if you pull a coin out of your pocket, you pull a quarter out of your pocket, I pull a quarter out of my pocket, they're interchangeable, right? There's no unique fingerprint that represents one quarter or the other. They're just exchangeable. That's all that means there. And so some high-level examples of fungibles, you know, you can use them to tokens. You can use them to store value, and so a virtual currency like a Bitcoin, you know, you can store value that is not tied to anything else, right? It's free floating, and that's just a virtual currency that's out there on its own. And there are many examples of those now today. A different flavor of a fungible token is a stable coin that is pegged, for example, to the US dollar. JP Morgan's coin that they've launched, and in the crypto world, there are many different kinds, like the US dollar tether, of these stable coins that are created. Again, a representation on some blockchain to represent, you know, a unit of hard currency somewhere else, like a US dollar. A final example of fungible tokens is Ether, the token that powers the Ethereum blockchain. It's sometimes called a utility token, and that just means that it has a specific purpose within the blockchain itself. So in this case, Ether, you must spend Ether, you must send Ether in to execute a transaction on the blockchain. So that's how you pay for your processing on the blockchain. You know, an insurance example, I took a pass at this, but I'm sure everyone on the call could do a much better job than me at thinking up examples. But subrogation is an area where value gets netted and transferred across parties on a regular basis. So maybe digitizing or streamlining that, a token could play a part in that solution. Now, obviously, there's more business logic that goes into it. Okay, moving on to what's called security tokens out there, and these are really kind of complex financial instruments that are very custom. So if a fungible token is, you know, a very concise few lines of code that has almost no functionality to it, it's just a coin to be passed from one party to the next. Security tokens can be arbitrarily complex. You hear them called security tokens or STOs. These are these financial instruments, you know, and the world has very complex instruments out there that exist, and the insurance industry is rife with examples of those, and the complexity is necessary, right, to govern the instrument itself and to define the terms. And so, you know, again, with these contracts, you can build them as complex as they need to be. You can involve as many parties as you need to be that need to be involved. And then finally, the NFTs, the namesake title of this series, are the non-fungible tokens. These are unique things, as Pat had recapped before. You dove into digital collectibles, and those get there's a lot of excitement out there for good reason. It's a new world for consumers who are in this digital space, owning unique moments in history or the equivalent of baseball cards or art, or even if you think about the gaming world and owning unique bits of the gaming universe, it's really cool. And there's a lot of innovation happening. But stepping down to the digital twin use case, more in the enterprise world, if you then expand that concept that, wow, real world things can also have a digital twin, and you start to think more about cars and houses and property, and things that are a little more ephemeral or like identities. We're really just scratching the surface of where we're going to be in 10 years' time, and digitizing all of those things. And some of them are so large that you really want to go to the largest blockchain possible and to have a common system that we rely on to build our next generation of applications. So that was a synopsis of the different types. You may be wondering at this point, okay, well, we can digitize anything in any way we choose. Why a blockchain? Why is the fit to digitize these things as tokens on a blockchain? What are the key reasons for that make that just a great fit? And that's part 3 or point 3 that I'd like you to take away, which is that tokens give a common view, so multiple parties that see that common view of trusted information. So think about how much you're willing to trust the information that this system, the server, is giving back to you about a thing. So on a blockchain, we can become what's called decentralized. So no one party has control over the blockchain itself. And that means that once the rules are set in code, you can't have a bad actor come in, a malicious actor, or maybe a good actor who's been taken over by a malicious party, and affect the system as a whole. We sometimes say in the blockchain space, we talk about immutability of the data. So by design, this data store, these transactions get chained together into blocks, and they build upon each other in such a way that you can't reach in and grab one of those transactions and change it. It's immediately obvious because everything else is chained together. So after the fact collusion or history rewrites or attacks on those or rollbacks of transactions can't be done by a single party or even a group of parties. And therefore, a second somewhat related topic is the idea of transparency of this data. Once you've written those rules and down into smart contracts, into code, you can choose to make those rules known to the parties as well. You can kind of because you have programmatic control over the asset or the token, the thing, you can choose how much of that to make visible. And you can therefore build transparency into the app that you're building. So the parties can stay in sync. They can know what the rules are, and everyone the relevant parties can be triggered when things happen, when actions are needed. And what we're seeing in the enterprise space is there are a certain set of attributes that are quite commonly important. Simple things like who has possession of this asset at this point in time, who owns it. You think about tracking goods through a supply chain, or food through a supply chain. Where is that thing right now? Our supply chains are so complex. Or who owns this piece of property? Which parties have insured this asset? And so you can build linkages across these tokenized things as well. And then being able to see the history is really important when you tie that to the concept of immutability, being able to trust the lineage of a thing, right? There are categories of assets where the lineage really matters. And then the current state, again, being able to define any sort of sets of attributes to put into that state. Everyone just instantly knowing what that state is really a powerful thing. And blockchains can be open. You know, how open depends on the blockchain that you participate in. We're now here in 2021. There are many blockchains out there. And I didn't put a great deal of detail into this presentation, but at a high level, there are public blockchains out there where the nodes that make it up are run by anonymous folks, and it's open. Whoever wants to run a node can, if you have enough computing power. And those public blockchains are certain categories of things are being deployed there. With Clydo, we tend to work with a different makeup of what's called enterprise blockchains or private blockchains, where enterprises can set up their own blockchain, right? And then the visibility, you can create gates, right, about who can see certain data. There's governance, what we typically call governance, that you can set up around the blockchain. You can have network operators like Ristream who are trusted parties, who are stewards of that governance and who take leadership roles in coordination amongst those parties. So enterprise blockchains aren't the Wild West, right? So we sometimes we hear in the news that, you know, some public blockchain, you know, some bad activity was happening on it, right? Whether it's money laundering or whatever. There's all kinds of examples out there. Enterprise blockchains are just fundamentally not that. They're much closer to, okay, you have hundreds of systems today. This is just another system that you're bringing online in your IT operations that you use to interact with your ecosystem. Okay, so in summary then, just to drive home these 3 points before I quickly go on to a few examples. Tokens are for enterprise. Enterprises need to collaborate on shared data, on things, on assets, and tokens uniquely solve this need in a way that hasn't been done before. They can represent anything or asset. They're highly customizable, flexible, programmable. Digital twins, we think, is a really important concept that we just haven't had before, a tool in our tool bag in the enterprise space. And they give us that common view that we can trust about a thing. So important attributes about those things. We can stay in sync with our ecosystem much easier. That's enterprise tokens in a nutshell. Those 3 thoughts.
Before we move on to examples, we have a couple questions here, if it's okay, and I think this is a good spot.
Sure. Let's take them.
The first one was from the question was, are tokens the equivalent of passwords? If yes, how are tokens any safer than passwords?
It's a good question. I wouldn't think of a token on a blockchain equivalent to password. And I know we're really bad about this in the IT space. We reuse words over and over again. Within the broader IT, there are types of tokens that are used somewhat similar to passwords, but blockchain tokens are not that. It's just a different thing. A blockchain token is much more like an asset or a thing that has a life cycle that exists on a blockchain and has the attributes that we've been talking about.
Got it. That's very helpful. Another question here is, how does a token differentiate from simply a hash of a given transaction recorded on a DLT or a blockchain?
Yeah, that's a good question. And hashing is let's say a 201 or a 301 topic in the blockchain world. It's a technique that's used that's becoming more prevalent. Let me give you a couple thoughts. First, just to level set, a hash is a mathematical function where you send in an input and you get back essentially a fingerprint of that thing, a representation of that thing. And so having these fingerprints where you can refer back to, let's say I have this big document. I don't want to store the big document. I can store a hash of that thing very concisely. I can store that fingerprint, and I don't want to show everyone the whole document, but I want to be able to prove later on, if I have the fingerprint and the document, hey, this hash correlates with this thing. And so hashes are used in all kinds of ways in blockchain scenarios to concisely store things. Where the touch point is with a token is, especially when we talk about digital twins, you need to bridge from the physical thing to the digital thing in a very reliable way, right? So how do you do that? Well, there are many ways to do that, and there's not one size fits all based on the asset. For example, for a diamond, you can read about use cases where people are taking high resolution photos, right? If you zoom in enough, each diamond is unique, right? And that photo is a digital representation of a physical thing. Another example is a car, right? We already have a unique ID for a car. It's a VIN, right? People have social security numbers, right, in the US. And so that bridging from the physical thing to the digital, a hash can be a shortcut, right, as a way to get a digital representation of that thing, and it's commonly done. Now, a token, when you create a token, part of when you just instantiate it, each instance is going to get a unique ID. It's just the way that things work in the blockchain world. You can't have two digital things that are sort of the exact same things of each other in the non-fungible space. So you can see how hashes could be used with tokens, but they're not necessarily required, and it depends upon the assets that you're working with, whether it's appropriate or not.
Very helpful, Steve. There are a few more questions coming in, but maybe we could field them right at the end.
Okay, very good. And I'll step quickly through a few examples here to leave some space for that. Okay, here's an example in the financial services space where the type of token, pop quiz, see who was paying attention earlier, but Union Bank is using a stable coin, tied, which is pegged to a real currency, to streamline remittance payments, cross-border remittance payments. It turns out that in third world countries, a lot of third world countries, this is a common use case. Someone goes abroad and sends money back, and how many hops that money goes through is surprising, and the fees that accumulate is surprising. And so streamlining that from 26 steps down to 5, from 30 days down to minutes, and saving in fees a week's worth of food is a pretty big wow, and is something that we've worked with Union Bank, and has been a live system now for a couple of years. We talked about supply chain and track and trace, and the traceability, luxury goods, tracking those, being able to show consumers that this is a verified good. They can track it back to where it was produced, and maybe there's a digital seal signature. It can really cut down on fraud, which is a huge problem for lots of categories of goods. I did want to plug Ristream a little bit. One of the projects that we did early on was a proof of concept in the life and annuity space around streamlining tracking mortality when a death event occurs. Death master records, we don't have a global concept of such, and so pooling data. This one is more of a, tokens could easily slot in a fungible token. So, a payment for a digital death record, right? So it's not the primary use case, but it can streamline digitizing that use case. If you can build in payments and value transfer, you can start to layer in incentives and get people much more engaged in use cases. And so that's common. We see, even if a token's not a day one thing in a use case, it pretty much always naturally fits in some way or other, because every use case is about a thing, right? It's about some asset, or whether it's digital or physical. A security token example, we're working with a top 10 bank in the world that has, very complex financial instruments. They're looking at streamlining those and automating those amongst a financial network of constituents. So this one's more in the consumer space. We're working with a partner called reinvent on a digital assets use case. Not just collectibles, things like coupons. A T-Mobile Tuesday campaign that we ran, where we can actually give better coupons to people, because there's less intermediaries, there's less fraud, there's less waste, and there's instant settlement. So these companies, there's a shockingly manual process to sort of reconcile how many coupons were redeemed and so on, even digital coupons. And we streamlined that all. And that resulted in much higher engagement rates around the coupon, because it was a better coupon. Central bank digital currencies is another space, that's rapidly emerging, and we're working a bit in that space as well. It's a whole category of sort of blockchain use cases I won't get into. Another track and trace around a tuna supply. So thinking about our natural resources and tracking those and the importance of that. In the NGO space, we're working on tracking the efficiency of the NGO agencies themselves and how they're spending money, and whether they're efficient, whether there's corruption and waste, and setting up and giving donors good information about those organizations, and digitizing that and streamlining that's another area. And tokens are used to what's called a token curated registry, if you want to Google into that term, was built into this use case. I mentioned digital coupons already, so I won't go on that one. The real estate's another area in the blockchain space. I think actually your third talk was going deep on this particular use case, but it's another area where there's lots of interest. Climate change, here's another one. So carbon credits, tracking those. Again, think about transparency, bringing a new level of transparency to tracking that's really important on an international basis, and it's something that we've actually have multiple projects going on in Clydo. Just another one. I'm trying to give you a snapshot so you can get the sense of the breadth of these use cases. Here's an ed tech one, right? So university courses and credits and degrees, thinking about how that's digitized, and the authenticity of those. Underneath it, minting a token when a student gets a degree that sort of says this student got this degree, and captures those attributes, is another really interesting use for tokens. Okay, and then just in the financial services space, settlements a big deal, whether that's cross-border foreign exchange, or even within a company, different business units settling from treasuries to maybe to other segments of the business, for example. So bringing real-time net settlement way down, and therefore just driving efficiencies up, just tokenizing all of those things. Okay, so I couldn't go into a ton of detail, but hopefully you get the snapshot of just how prevalent we see enterprise tokens becoming. There are a few case studies if you want to go deep out on the Clydo website that I recommend to you. So that's it for me, Pat. I want to turn it back over to you, and we can go back to the questions.
Sure thing. So Steve, thank you so much for a really great session here today. We do have a couple questions, and I know we're a little over, so if folks do need to part, feel free to jump off, and we'll be sure to follow up with some information related to today's session. But maybe we can go ahead and try to field some of these existing questions that are out here. One of the first questions was related to identity from Sumita. That question was related to a slide that was shown earlier. It mentions that it's interesting that we recognize the identity of things as a digital twin, but not necessarily refer to the identity as an NFT or a digital twin. Is there thoughts, Steve, that maybe that's an oversight, or is it people's fear of simplifying a subject that has been made complex? So that was a question from Sumita.
So there is an entire category of innovation in the blockchain space. It's sometimes called decentralized identity, to rebuild digital identities. I'm talking about people's identities, your online identity, your actual, and the proof of identity that you use to open a bank account, or to show that you're 21 to get into a bar. Fundamentally reinventing that. And I think there's an argument that it's just shorthand here. Essentially, our digital identity is somewhat broken. It's sort of controlled by very large tech companies. It's sort of centralized and aggregated your online identity. And then sort of the physical uses of your identity has not really been digitized that well yet. And so kind of taking all of those things together and thinking about, again, it's called decentralized identity or self-sovereign identity, and thinking about that problem as a whole, and what should 21st, how should your identity work in a 21st century world? So there is a ton of activity in that space, but as you might imagine, something that grand of scale is going to take some time to come into effect. But I'd encourage you to Google self-sovereign identity or decentralized identity if you want to learn more about that.
Very helpful. One final question here that we have. If we use an NFT as a digital twin to a physical asset and we transfer the ownership of that token to another party, the question is, how do we ensure the physical asset is actually transferred as well? How do we ensure the digital twin remains representative of the quality of the physical asset? I.e., what if the physical asset is damaged or destroyed? Any thoughts on that, Steve?
Yeah. Well, I think that's when you talk about digital twins, the linkage between physical and digital is the most crucial piece. Once it's digitized, you can do things very efficiently, you can automate, and so on. But the question is correct. The digital representation is only as good as it is accurate to what's going on in the physical world. And so, a lot of the time, when you look at digital twin use cases, most of the effort from a project perspective is in thinking through that physical to digital linkage. There are a combination, there are many techniques that depend upon the use case itself, as far as how you can solve that problem, chip away at that problem. Not sure that any one solution in of itself is 100% accurate, but a couple examples that I've seen, thinking about a batch of avocados, right, and how do you digitize those? Well, you could, obviously there are stickers that are put on with barcodes that can be scanned, when those avocados are on a shipping vessel, then now more and more you're seeing the containers have emit data about the temperature, right? If temperature goes above a certain degree, you want to trigger an insurance claim, right? Because it's a perishable good and it's been destroyed. So tying, then I think you start to see how complex of a problem it is. It's not just the avocado, it's the fact that avocado was put into this particular container. Something happened to that container, and so on. And so you kind of have a chain of events, a chain of custody, but ensuring the accuracy of that is a major challenge, but it is solvable, through to a certain degree of reliability. And depending upon the use case, you don't want to overinvest in solving that problem. You want the reliability and the confidence level to be as good as required. There are, again, a set of techniques that you can use together. I mentioned the diamonds and high resolution photos. I think another thing, final thought here, every transaction on a blockchain also tracks the identity of the organization, the signatures of the parties that are attesting to certain things. So if De Beers is saying, hey, we mined this diamond in this place, then part of what you're assessing is the fact that it's De Beers' signature that's on that particular transaction that's stating that thing about that token. So when we say it's trusted information, what you can trust from the blockchain is that De Beers' identity said that thing, because that's stored immutably. You need to think about trust comprehensively and holistically, and that's relative to the parties involved, and to some of these other techniques that we're using to bridge physical and digital.
Very, very helpful. And I want to, on behalf of the Restream Collaborative, again, thanks so much for your time here today. Great session. We really appreciate you sharing your perspective with us, Steve.